Okay, good evening. I think you can see the slides now. Okay, my voice is also audible. Please check it. If there is any problem, you can inform me. I think this is the last column. So this is the last problem, problem 1.12 we discussed in the last class. Okay. Okay. The next problem is okay. The next problem is show that the sequence 6 comma, okay, there are 4 6 6 6 6 6 4 3 3 0 is not graphical. Okay, maybe I'll write here. Okay, it's not graphical means using this degree sequence we cannot draw a graph. So 4 6 and 4 3 3 0 4 comma 3 comma 3 comma 0. So let us take this is A B C D E F G H. I will take this is something like P1. Okay, so first I will take this 6. Okay, if I take the first two vertex, first it should be ascending order, descending order. Okay, I will take this 6. I am going to subtract this 6 from the from here. From here, if I subtract 6 minus 1, I'll get 5. From each one, I am going to subtract one. Okay, number 1. Okay, 6 minus 1 5. Here what? 6 minus 1 5. So totally here have what? 6 ones. Okay, 6 ones I am going to subtract from each one. 1 2 3 4 5 6. So from here again I'll get what? 5. Here we'll get what? 3 4 minus 1. Here what? 3 minus 2, 3 minus 1 is 2, and 3 minus again 1 2. So 1 2 3 4 5 6. Okay, this 6 is I am subtracting from the first 6 elements. Each one I am subtracting 1, and finally you should keep this one 0. Okay, now this is whether check it whether this is ascending order or descending order or not. Yes, I think this is in descending order. I'll write this is what? B, this is C, D, E, F, this is F, this is G, this is H. Again, I'll take this 5, I'll do the same thing. 1, 2, 3, 4, 5. Okay, so for 4, 4, 2, 1, 1. Again, this is 0. So this is what? C, D, E, F, G, H. I will take this. Okay, check it. This is in descending order. Yes, it is a descending order. I'll take this 4. So 1, 2, 3, 4. So here what? 3, 1, 0, 0. Okay, I subtracted 4 from the first 4 numbers. Each one I subtracting 1. So final keep 0. So now this is what? D, E, F, G, H. Now I'm going to just I'm going to try the graph, okay, using the last one. So these 3 are what? F, G, H. Okay, I'll put D. This is D. This is what? E. So F, G, H degree 0. Okay, so that means it is not adjacent to any other vertex. So now using these two vertices, you should make the degree of 3 is what? 1, and the degree of E is what? 1. So that is not possible. So using this degree sequence, the degree sequence is what, 31000. Using this degree sequence, we cannot draw a graph. So and hence using the given degree sequence, we cannot draw a graph, because here it is very difficult to tell if I give these numbers. But here this is you can easily tell whether you can draw a graph or you cannot draw a graph using this degree sequence. So we reduce the problem, okay, and then we are checking using this degree sequence whether we can solve, we can draw a graph or not. If it is possible to draw a graph using this, you can also draw a graph using this. If it is not possible, if it is not possible to draw a graph using this degree sequence, means using this degree sequence also is not possible. So it is mentioned. It is also explained here. Okay, if you want, you can check it. The finally you'll get what, 3 comma 1 comma triple 0. The same thing we are getting, 3 comma 1 comma triple 0. So since there exists no simple graph having what, one vertex 3 and the other vertex of what, degree 1. The last sequence, this is the last sequence, is not graphical. Not graphical means we cannot draw a graph using this degree sequence. Hence the given degree sequence, this is a given degree sequence, is not graphical. Not graphical means again we cannot draw a graph using this degree sequence. Okay. The next problem, show that the following sequence is graphical. Also find the graph corresponding to the sequence. So okay, I'll write 655, 6 5 5 4 3 3 4 3 3 2 2 4 3 3 triple 2 2 2 2. So we show that this is graphical. Okay, graphical means we can draw a graph. Also find a graph corresponding to this degree sequence. We should draw a graph also. Okay, A, B, C, D, E, F, G, H, I. First, I'll take this 6. If I subtract the 6 from the first 6 numbers, 1, 2, 3, 4, 5, 6 up to G. Each one I'm going to subtract 1. 4. Okay, I'll give some space. 4, 4, 3, 2, 2, 1. 1, 2, 3, 4, 5, 6. Okay, now remaining 2 you should write as it is. Now you should write in the ascending order. Okay, ascending order. If I write in the ascending order means first 4, 4, 3, 2, 2, 2, and then write these two twos, 2, 2, and then finally write what, 1. So this is actually what, B, B, C, B, C, D, E, E, F, okay, F, and this is what, H. Okay, this is what, this 2 is what, H. This 2 is what, I. This 1 is corresponding to what, G. Okay. Next, I'll take, this is P1. This is P1 dash. This one. Next, this is P2. Next, P2 dash. P2 dash is again. I'll take this 4. I'll subtract from first 4 elements. Each one is from 1. So 3. 4 minus 1, 3. 3 minus 1 is what? 2. 2 minus 1 is 1. 2 minus 1 is 1. So I subtracted this 4 from the first 4. And then keep the remaining thing 2, 2, 1. now write in the ascending order. Ascending order means first 3. This is what? 3 is what? C, yeah? C. And this 2 is D. Okay, and then this 2. Okay, 2. This is H. This 2 is what? I. This 2 is I. Okay, and then this 1. This one is E. This one is F. This one is G. Okay, I'll write in ascending order. This is P3. Okay, now I'll take this 3. I'll subtract from the first 3. Okay, so 1, 1, 1. So I subtracted these 3 from the first 3. Each one I subtracted 1. So I'll keep this one 1, 1, 1. So this is what? D, H, I. Because now it is in descending order. Okay, so all of them are 1. I don't have any problem. E, F, G. So D, H, I, E, F, G. Now the last degree sequence is graphical. So we can draw a graph using this degree sequence. You can see how we can draw D, H. Okay, D. Okay, H. D, H. And just join, and then I, E. Okay, I, E. I just join. Degree is what? 1, 1. I, E, and then F, G. F, G is 1, 1. F, G. But this is actually what? The degree sequence is what? 1, 1, 1, 1. All of them are 1. All the 6 vertices are what? Degree 1. So this is graphical. So even it is a disconnected graph, but it is we can draw a graph. Now next one, I should take this one. Okay, which one? See, okay, here I will take first. I took this one. I'll put it something like red. First I took this degree sequence. Next I am going to take what? P3. P3 means this degree sequence. Here, which is a new vertex, C is added. Okay, so I'm going to add the new vertex to C. So I'll put C here. This is C, new vertex. The remaining everything is same. The remaining everything is same. That is what? D, H, I, E, I, E, and then F, G. This is D, E, H. Okay, now what is the degree of C? Degree of C is 3. I should add to what? These 3. D, H, I. D, H, I am going to add 1, 1, 1. So D, okay, D, H, D, H, I. Okay, now the degree is what? 3. Remaining everything is same. So now you can check the degree. Degree of C is what? 3. Degree of this is degree of C is 3. Degree of 2 is D is what? D is D H I or D H I is what? 2, 2, 2. D H I is what? Degree 2. Okay, F is E is what? Degree 1. Check பண்ணிக்கணும். E is degree 1, F is degree 1, G is degree 1. E, F, okay, all degree what? 1. So there is no need to write the degree here. Just for understanding, I am writing. Here you can write what? 3, 2, 2, 2. Okay, 3, 2, 3 2s, அப்புறம் 1, 1, 1. 1, 1, 1. So using this degree sequence, I draw a graph. Next, I should take which one? Yes, P2. P2 I should take. Here, what is the new vertex? B. Remaining everything is same. So again, I should draw a new graph. Okay, maybe here I'll do it. Here I'll put it B. The remaining thing, just I will do. I'll just copy from here. C. This is C, and then here there are two vertices. Here there are two vertices. Here there are two vertices. Okay, DH, DH, IEFG, IEFG. So originally it was there like this. Now from C we joined what? D, C to what? H, C to D, C to H, C to I, C to I. Now I added B. What is the degree of B? Degree of B is 4. I should add these 4 to where? In C1, D1, E1, F1. So C, D, E, F. C, D, E, F. C, D, E, E, F. Okay. Now, if you want to check it, here you can write the degree sequence. What is the degree of B? 1, 2, 3, 4. I'll write 4. Okay. Okay, I'll write here, I think 4 comma 4. Degree of B is what? 4. Degree of C is what? Degree of C is 4. 1, 2, 3, 4. Degree of C is also 4. And then degree of C 4. Okay, degree of D is what? D is 3, E is 2. Okay, first D is 2, 3. D is 3. D is what? 1, 2, 3. Okay, D is 3. Next, E, F, H, I. All of them are what? 2. G is 1. E to I. E to I 2. E is 2. F is what? 2. E, F, G. Sorry, not G. E, F, E, F, H, I. E, F, H, I. Okay, E, F, E is 2. F is 2. H is 2. I is 2. Okay, so finally G is 1. Yes. 2, 2, 2, 2, 1. Okay. Next graph and the last graph, this one. Okay, so 6. Okay. Now I'm going to add one more vertex A. So A is degree 6. Okay, maybe I will draw here. I'll put here A, or better I will do it somewhere else. Okay, I'll put it here maybe. It's here A, here remaining thing. Okay, remaining what? B, this is B, and then C is here, C is here, D, E, okay, this is D, this is E, H, and then I, this is E, this is F, G, F, G. So first you should draw the this graph. Okay, so this should join, this should join, here you should join this, and then C to D, C to H, C to I, okay, and then B to what? B to D, Okay. So B to B to D, B to D. Okay, I think it is coming black cloud. Okay. So actually, this is actually D. D. So B to D, B to D. Okay, and then B to C is also there. B to C, B to E. So these are all just a drawing this graph, and then what? B to what? F. Okay. Now I introduce A. A is degree 6. Okay, A is degree 6, and then I'm going to check. Now I'm going to add this A, where 6 degrees to B, C, D, E, F. 1, 2, 3, 4, 5, 6 up to G. B to G. I am going to add one each one. Okay, B to G. B one. Okay, B, C, C, B, C, D, again E, E, F, F, G, 1, 2, 3, 4, 5, 6, F, H వరకు. Okay, F, I joined F and then H. Okay, now what is the degree of A? 1, 2, 3, 4, 5, 6. So the degree sequence is what? 6, and then degree of B is what? 1, 2, 3, 4, 5. So 6 comma 5, you can check it. 6 comma 5. C is also 5. C is 5 means check 1, 2, 3, 4, 5. C is 5. D. What is D? D is 4. D is 4. 1, 2, 3, 4. Okay. But draw the graph little bit clarity. Okay. Here it is not that much good. So draw neatly. A, B, C, D. And then E is what? E, F is 3. E, F. E is 1, 2, 3, 3. F is also 3. 1, 2, 3. F, F. And then G is what? G, H, I. Everything is 2. G, H, I. Okay. Here I think G. Okay. I think I done the mistake. 1, 2, 3, 4, 5, 6. Okay. I think here G is 1. Here G is 2 means 1, 2, 3, 4, 5, 6. I should add A to G வரைக்கும் தான் போட்டுருணும். ஓகேவா? A to G தான். இப்போ ஹச்சுக்கு பண்ணிட்டேன். ஓகேவா? A to B, A to C, okay, A to C, A to D, A to E, A to F, and then A to G. I drawn A to H. That is wrong. This will not come. Okay, so A to G. So now we can see the degree of G is what? Okay, this is A, B, C, D, E, F, G. G is also what? Degree 2. Okay, G is degree 2, H is degree 2, I is degree 2. H is degree 2, 1, 2, E, F, G. H is degree 2, I is degree 2. This is I. Okay, this is I. This is 1, 2. Okay, sorry. Here I put 2, here H, and then put 2, here what? I. So now this is the required graph for this degree sequence. But, but you can easily draw. Okay, so this problem is over. Next problem. I think here in this problem they done some mistakes here. Okay, I think maybe in this step I think they done the mistake. I think so, or this step or this step. I don't know exactly. You should carefully go through it. I think this is. I feel this is correct. Okay. If suppose if there is any mistakes, you can send me a message. I will check it. Okay. The next problem is determine the number of edges in the graph with 6 vertices. Total number of vertices is 6. They are asking the number of edges. Okay, but they gave some hint. So what is the hint? Two of them are what? Degree 4, and four of them are what? Degree 2. So draw two such graphs. Okay. So here you can see here sum of the degree of the vertices equal to twice the number of edges. That is we know already. So totally how many vertices? 6 vertices. So degree of V1 to degree of V6 is equal to 2e, twice the number of edges. So we know that two vertices are what? Degree 4. So 4 plus 4. And 4 vertices are what? Degree 2. So 2, 2, 2, 2 equal to 2e. If you add everything, 16 equal to 2e means the number of edges is what? 8. So now we are going to draw a graph using 6 vertices and 8 edges, and two of them are what? Degree 4, and four of them are what? Degree 2. So I think this graph is the second graph is slightly easier because here the degree is what? Either 2 or what? 4. So if it is like this, you will get a complete bipartite graph. So if I take two vertices here I will take what? 4 vertices. So if I join these two vertices to every one, you'll get what? Degree 4. Similarly, if I take join this here to everyone here what? Degree 4. So similarly here all the 4 vertices are what? Degree 2. So this is one such example. Okay. This is also another example. Okay. So this first you can draw a C4 like this. Okay, and then you can draw like this. Then you get what? These two vertices are what? Sorry, these two vertices are degree 4, and the remaining 4 vertices are what? Degree 2. I feel this one is slightly easier. Okay, hence I think we solved this problem. Okay, now next. Okay, how many vertices are needed? Here they are asking number of vertices. Okay, to construct a graph with six edges in which each vertex is of degree 2. Okay, I don't know the number of vertices, but again I'm going to use this lemma. Okay, the sum of the degrees of vertices equal to what? Twice the number of edges. Okay, so 2 into q is what here? Number of edges is what? 6, so 12. So that's why I'll write degree of v1. I'll take there are p vertices, okay, in the graph with not 6 degrees, okay, 6 edges. Okay, there's a typo because they gave only 6 edges in the question, but each of them are what? Each of the vertex is degree 2 only. Okay, suppose there are p vertices in the graph with you can write what? 2 degrees. Okay, not 6 degrees. So p vertices, that's why I'll write but here they'll put p, here they'll put n. So either you put here n na, here n. So better to put what? Here p na, here up to what? Degree of v1 plus degree of v2 up to what? Degree of vp. Keep this is degree of vp. Don't write vn. So equal to 2 times what? 6, 12. So each degree is what? Here it is given what? 2. So I'll add 2, 2, 2, 2 equal to what? 12. How many times? P times. So 2p times means 2p equal to 12. So p equal to what? 6. So we need 6 vertices to draw this graph. Okay. The next question is it possible to construct a graph with 12 vertices such that uh, two of the vertices have what? Degree 3 and the remaining vertices have degree 4. So these types of problems usually they don't ask. Okay, maybe the previous question is okay. This is okay. This is fine. This is also fine. But okay, just I will explain this problem. Again, sum of the degrees of vertices is equal to twice the number of edges. Total number of vertices is what here? 12. 12 vertices. Two of them are what? Two of them are degree what? 3. Remaining means 10. Remaining vertices are degree 4. So 10 into 4 equal to twice the number of edges. We don't know the number of edges. So 6 plus 40. 46 is equal to 2e means e equal to 23 edges. So it is possible to construct a graph with what? 23 edges. And 12 vertices is given in the question, which satisfies the given condition. What is the given condition? Two vertices have what? Degree 3 and the remaining vertices of degree 4. So actually e equal to 23 is the answer. So E equal to 23, and then we should check it whether E equal to 23 is possible, because the number of vertices is what? 12. So maximum number of edges is what? Okay, suppose uh, if we have n vertices, the maximum number of edges is what? N into n minus 1 by 12. So now here here 12 vertices means maximum number of edges is what? 12 into 11 by 2. So it is 66 edges. Okay, but maximum 66. But okay, if it is exceed 66 means we cannot draw a graph. But it is less than what? 66. Maximum is 66. But 23 is what? Less than 66. So okay. So we can construct a graph with the 23 edges. So this problem is uh, they will ask. This is a nice question, but simple. They are testing your uh, basic concepts. So the question is it possible to draw a simple graph with 4 vertices and 7 edges? Justify your answer. So 4 vertices and 7 edges. Okay. So just now I told that in a simple graph with the p vertices, maximum number of edges is what? P into p minus 1 by 2. What is the number of vertices? 4. So 4 into 3 by 2. So only at most you have what? 4 vertices have at most 6 edges. But here they gave what? 7 edges. So the simple graph with 4 vertices cannot have what? 7 edges. Hence, such a graph does not exist. So I think this problem is last class we discussed. So that's why I'll skip here this one. Delta of g less than or equal to 2 times cardinality of, actually instead of this I proved delta of g less than or equal to 2 times q. Okay, instead of cardinality of E, I'll put what? 2 times Q by cardinality of E is what? P less than or equal to delta of G. Just I will show you where it is. Yes. So 2Q by P lies between what? Small delta and what? Capital delta. So instead of Q, they are writing what? Cardinality of E, number of edges. Instead of P, they are putting what? Cardinality of V. So the proof is last class I explained. This is a repetition. That's why I don't want to do again. Okay, next problem. A graph has two vertices of degree 5. Two vertices of degree 5 and four vertices of what? Okay, I'll write two vertices of degree 5. Two vertices of this. We know that sum of the degrees of vertices equal to twice the number of edges. I'm going to use that one. Two vertices have degree 5 and four vertices have degree 4. Four vertices have degree 4 and three vertices have degree 3. Three vertices have degree 3 and one vertex have degree 1, one vertex have degree 1, okay, and 22 edges, okay, 22 edges. How many vertices of degree 2? How many vertices of degree 2? So I don't know, okay, degree 2, how many vertices? That's why I'll take 2x. How many vertices have degree 2? Degree 2, but x is what? X is the number of vertices of degree 2. Okay, x is the number of vertices of degree 2. But which is equal to twice what? The number of edges. What is the number of edges? 22. Okay, 2 into 22. So in the question they are asking how many vertices of, you can check it. Yes, how many vertices of degree 2 does the graph have? So how many vertices of degree 2? That means we should find x. So 10 plus 16 plus 9 plus 1 plus 2x is equal to 44. So 10 plus 10, 20, 36. So 2x is equal to 44 minus 36. So 2x is equal to 8. So x is equal to 4. So there are 4 vertices of degree 2. Okay. So x equal to 4. Okay. So x is what? X is denote what? The number of vertices of degree 2. Okay, this is the answer. Okay, the next problem is let G be a P comma Q graph such that all the vertices have what? Degree k or degree k plus 1. So either degree k or what? K plus 1. If G has t vertices of degree k, show that t equal to p into k plus 1 minus 2q. Okay. So now, uh, okay, here either they have degree k or what? K plus 1. If G has t vertices of degree k, okay, so it has either degree what? K or k plus 1. So degree k, how many vertices? T vertices. So and hence degree k plus 1. Total number of vertices is p, means because it is a p comma q graph. Total number of vertices p means k plus 1. Remaining of k plus 1 means p minus t. Okay. So sum of the degrees of vertices equal to twice the number of edges. So kt plus, okay, because degree k is k times, degree k plus 1 is what? P degree k plus 1 is p minus t times. So which is equal to twice the number of edges. 2 times what? Q. 2 times Q. So tk plus, okay, you can see here, tk plus p minus t into what? K plus 1 equal to 2q. So if you simplify, you can get t. So kt plus kp minus kt plus p minus t, which is equal to what? 2q. So here it's yes, kt minus kt gets cancelled. Okay, so t equal to uh, kp plus p minus 2q equal to what? T. So t equal to k plus 1 into p minus 2q. So we'll check it. T equal to k plus 1. Yeah. T equal to k plus 1, k plus 1 into p. T equal to k plus 1 into p minus what? 2q. Minus 2q. So this is the final answer. Okay. Next, a regular graph of degree 3 is called a cubic graph. So already, I think maybe in the previous class, we discussed cubic graphs. I gave the example also. For cubic graph, what is the example? K4, complete graph on 4 vertices is an example for cubic graph. Okay, so cubic graph means it's a regular graph. All the vertices what? All the vertices of degree 3. Okay, so the problem is here. We need to prove that every cubic graph has an even number of points or even number of vertices. Okay, so cubic graph have even number of vertices. Okay, we know that again. I'll start from sum of the degrees of the vertices. Okay, vertices equal to what? Twice the number of edges. Okay, twice the number of edges, twice the cardinality of it. Okay, this is actually even number. Okay, twice is a multiple of 2 more, that's why it is a even number. But this is a general result, we know that. But in our problem, okay, V belongs to capital V. So in our problem, it is given. What is given? Okay, so V in capital V, degree of V. So each vertex is, it's a cubic graph. Each vertex is what? Degree what? 3. So each vertex is degree 3 means you should add 3 plus 3 plus 3. Okay, how many times? So totally, if you take n times, n vertices. Suppose it has n vertices, you'll get what? 3n. Okay, the left hand side is same. Okay, sum of the degrees of vertices. Here also what? Sum of the degrees of vertices. The left hand side is same means the right hand side is same. What is the right hand side? Here 3n. Here it is what? Even number. 3n equal to what? Even number. 3n should be even number. So we know that 3 is what? Odd. Okay, wow. So n should be what? Even. So then only you get what? Even number. This implies n is what? Even number. So and hence we proved the result. That is the result we need to prove. And what is the result we prove? Every cubic graph has even number of points means even number of vertices. So here you are assuming what? N is the number of vertices in this graph. We proved n is what? Even. Even or even number? Okay. So again, this is comes under graphical. So 444, 222. Okay. Just I will explain quickly. Is graphical or not? So you should write first 444, 222. I should, okay, A, B, C, D, E, F. So here I'll take this 4, I'll subtract from the first 4. So you'll get what? 3. Here you'll get what? 3. Here you'll get what? 1. Here you'll get 1. And then you'll keep these 2 as it is. Okay, now this is not in the descending order. That's why I'll write this one in the descending order. So 3, this 3, and then this 2, this 1, this 1. Okay, this is actually B. This is what? C. But this 2 is what? F. F. This one is what? D. This one is what? E. Now it is in descending order. Okay, so I'll take this 3 and then subtract this 3 from the first 3 elements. Each one 1. I'm going to subtract. So 2, 1, 0. I subtracted this 3 from the first 3. So and then put 1. So again, you should write in the descending order 2, 1, 1, 0. So this C is what? This 2 is what? C. This 1 is F. This one is what? E. This 0 is D. Now, for this, is it possible to draw a graph? I am going to check. Okay. So I'll put a D because D is 0. D. And then F is what? Degree 1. Okay. And C. This is C is what? Degree 2. E is what? Degree 1. Actually, this is a graphical. Okay, but even though this is disconnected, this is what? Graphical. Next, I cannot take this one. I should take this one. Yeah, because this is in descending order. So now, from what is the difference between these two? Here I need to add what? One more vertex B. So I should join this B to where? C, F, D. Check for me. Please check it. C, I join to B to what? C, and then B to what? F, B to D. This D is here. Okay. So first you should keep this graph and then you should add one more vertex B. From B, you should add a edge to where? C, and then what? C, and then F, and then D. So check it. The degree of B is what? 3. Degree of C is 3. Degree of F is 2. Degree of D is 1. Degree of E is 1. Okay. Now I got this graph. From this graph, next this one. Okay. I should take this one. Here I should add A. From A to I should join B, C, D, E. So this is A. Okay. I should add to what? B here, and then C here, and then D here. Okay. And then E here. Okay. First 4. Keep don't disturb F. Okay. F is degree 2. So now check it. Degree of A is what? 1, 2, 3, 4. Okay, 4. Degree of B is what? Here it is 3 means here it is 4. 1, 2, 3, 4. B. C is what? Degree 4. Yes, 1, 2, 3, 4. Okay. E is what? Degree 2. 1, 2. E. F is also degree 2. Okay. So already I solved 2 problems. So that's why I don't want to do it again. Just I explained here. If you have any doubt, you can contact me in this problem. Okay. Finally, we can draw a graph. So and hence this is graphical. Okay. This degree sequence is graphical. So this is again one more problem. Just you can try. Is the partition 5, 3, 5, 3, 2 remaining how many ones? 1, 2, 3, 4, 5, 6 ones is graphical sequence. If so, construct a graph attains the sequence. Just I will explain only this portion. You can draw a graph. So first I'll take 5. 1, 2, 3, 4, 5. From the first 5, I am subtracting each one from 1, 1, 1. Okay. So 3 minus 1, 2. 2 minus 1, 1. Here what? 0. Next to 0. Next to 0. And then 1, 1, 1. First, I should write in the descending order 2, 1, these 3 ones, and then 0, 0, 0. This 2 is corresponding to B, this 1 is corresponding to what? C. These 3 ones are corresponding to what? GHI. So I should write GHI. These 3 zeros corresponding to what? DEF. Okay. Now it is in descending order. I'll take these 2 from the first 2 positions. I'll subtract from first one. Okay, each one from I'm going to subtract 1. So 1 minus 1 is 0. 1 minus 1 is 0, and then 1, 1, 0, 0. Okay. Now, if you want to write, you can write this is in descending order. So you should write what? 1, 1, and then remaining everything is what? 0. Okay. So after writing this, okay, H and I what? Degree what? 1, 1, 1. Remaining everything is what? C, G, D, E, F. All of them are what? Degree 0. Actually, this is graphical again. So even here it is not disconnected graph, but it is graphical. Now from this, I am going to add one more vertex. Okay, B. Yeah, I should join B to where? C and G. I put here. I put it. I'll keep this graph here. Here HI. I'll put remaining what? C to F. C to F is here. I'll add one more vertex B, whose degree is what? 2. But you should add to where? You should add to that B to where? C and G, because C and G is what? 1. C 1, G 1. B is what? Degree 2. And H is 1, I is 1, D, F is what? 0. Now from this I should go to the this given degree sequence. So I am going to add one more vertex A. So I should add one more vertex A here. What is the degree of A? 5. I should add to where? B to B, C, D, E, F. So A to, I should add A to B. A to what? C. And then A to C. A to D. Next to A to D. A to what? E. Okay, A to F. A to A to B, A to C, A to D, A to E, and then what? A to, this is F. Okay, now degree of A is what? 5, degree of B is 3, okay, check it. Degree of C is what? 2, degree from remaining everything is 1. D1, E1, okay, F is 1, G is 1, H is 1, I is 1. So again, this is a disconnected graph only, but this is again graphical. Okay, we can draw a graph, but it is not connected, but it is disconnected. So the question for the question, this is the partition is graphical sequence? Yes, the partition is what? Graphical sequence. Check the time, maybe. Okay, maybe this is the last problem. Okay, the maximum number of lines, or maximum number of edges among all p points graphs with no triangle is p square by 4. Okay, so what is given the question? The maximum number of edges among p vertices graph with no triangle. No triangle means it does not have a C3. Okay, C3 or K3. This is a triangle. Okay, it does not contain a C3 or what? K3. Both of them are C3 or K3. Okay. So E is what? P square by 4. Maximum number of edges. So how many vertices it has? P vertices. Okay. Maximum how many edges? They will put this bracket P square by what? 4 edges. They tell what is the meaning of this. So this X, okay, this X denotes what? Greatest integer not exceeding the real number X. So this is same as floor P square by 4. So this is also what? Greatest integer not exceeding P square by 4. So these two are same meaning. Okay, now uh, the result can be easily verified for P less than or equal to 4. So okay, I can write directly. So maximum number of edges is what? Okay, suppose if I take P equal to 1. P equal to 1 means only one vertices. So now what is the edges? Q. Edges is for this graph is Q is what? 0. Okay. So you can check it here. If it is 1 by 4 means P is 1 means 1 by 4. So greatest integer not exceeding 1 by 4 is equal to what? 0. So both of them are 0. For P equal to 1, the result is verified. P equal to 2. That means 2 vertices. Maximum number of edges is what? 1. So Q equal to 1. But you will check it here. They are telling that what? Maximum number of edges is what? But no triangles. Okay, that is most important. P square by what? 4. So P equal to 2 means 2 square 4 by 4. The greatest integer not exceeding 4 by 4 is what? 1. So here also 1, here also 1. So both of them are same. So P equal to 2 is verified. Next to P equal to 3. P equal to 3 means I cannot draw a C3 because this does not contain what? Triangle. I can draw a path like this. Okay. So maximum number of edges is what? Here 2. So now 3 square by 4. 3 square by 4 is what? 9 by 4. So what is the 9? What is 9 by 4? The greatest integer not exceeding 9 by 4 is what? 2. Okay. So Q here also 2, here also 2, up to Q P equal to 3, we verify. Next to P equal to 4. 4 vertices. 4 vertices means 1, 2, 3, 4. So it does not contains C3. Okay. Can draw like this, or you can draw like this. Here also P is 4. But here the number of edges is what? 3. Here number of edges is what? 4. That's why, but the question is what? Maximum number of edges. So that's why I'll take this one. So here what? Q equal to 4. So now Q's, what is the number of maximum number of edges? P square by 4. P, what is P here? 4. 4 square. 4 square is what? 16. 16 by 4 is what? 4. The greatest integer not exceeding 4 is 4. So which is equal to 4. The number of edges is what? Maximum number of edges is 4. Okay. So now we verified up to P less than or equal to 4. Now we are going to prove the result is true for what? P greater than 4. So we are going to prove by mathematical induction separately for odd P. Okay, for case 1 is what? Case 1 or part 1 is what? P is odd. Okay, next case 2 or part 2 is P is what? Even number. Okay, now first case P is odd. Suppose the result is true for all odd P's less than or equal to 2n plus 1. So that means what is the meaning? Suppose G is a graph with 2n plus 1 vertices and no triangle, then the maximum number of edges in that graph is what? 2n plus 1 whole square by 4. So that is the meaning. Okay. So suppose G is a P comma Q graph with P equal to 2n plus 3, because we assumed up to 2n plus 1 the result is true. The next odd number is what? 2n plus 3. So that's why I am taking G is be a P comma Q graph with the P equal to 2n plus 3 vertices and has what? No triangle in this graph. If Q is what? The number of edges is 0, then automatically Q is what? Less than or equal to P square by 4. Okay, this is trivial case. Okay, hence we assumed Q is what? Greater than 0. Let U and V be a pair of adjacent vertices in G. Okay, so I will draw a graph like this. Suppose this is U and V. I'll take this is U, this is V. Okay, it's a pair of adjacent vertices in G. Okay, now the subgraph G dash. Okay, this is I call this is G dash. Okay, G dash. Actually, G dash is what here? G dash is G minus. And from G, I am removing what? The vertices U comma V. I am removing the vertices G comma V. So including this graph, this okay, including this is G. Okay, this and this. Okay, everything is G, but this is only what? G dash. This is G dash. Yeah. Now from G, I removed U and V. Okay, that is called I call G dash. Okay. Next. So okay, in G dash, how many vertices? Okay, in G, how many vertices? Sorry, in G, how many vertices? In G, 2n plus 3 vertices. So in G, 2n plus 3 vertices. So in G dash, 2n plus 1 vertices. So by induction hypothesis, if it is 2n plus 1 vertices, the result is true. What is the result is true means? The maximum number of edges, okay, is what? With the maximum number of, because we assumed it has no triangle, the maximum number of edges in G dash is what? The maximum number of edges in G dash by mathematical induction. The maximum number of edges in G dash is what? 2n plus 1 whole square by 4. This is by what? Mathematical induction. So that is given here. Okay. So Yes, G dash is equal to G minus UV. G dash has what? 2n plus 1 vertices, because G has what? 2n plus 3 vertices. So G dash has 2n plus 1 vertices and no triangle. So hence by mathematical induction, Q means number of edges in G dash. Okay, less than or equal to what? P square by what? 4. What is P? Okay, number of edges in. Okay, what is P here? P is number of vertices in what? G dash. That is what? 2n plus 1. Okay, a whole square by 4. Okay. Now this is equal to a plus b whole square formula. 4n square plus 2a become 4n plus 4 by 1. Now throughout divide by 4, you get what? N square plus n plus 1 by 4. So what is the greatest integer which is not exceeding n square plus n plus 1 by 4? Is nothing but what? N square plus n. So the maximum number of edges, sorry, the maximum number of edges, yes, the maximum number of edges, I will write here. Okay, the maximum number of edges. Okay, maximum number of edges in G dash is what? Maximum number of in G dash is n square plus n. Okay, n square plus n. Okay, this is the first observation. Our aim is to find the maximum number of edges in what? G. So now, just now we found the maximum number of edges in G dash is what? N square plus n. Okay. So since G has what? No triangles. Yeah, we assumed what? G has 2n plus 3 vertices and no triangles. Okay. I will draw it. Okay. And then they are telling that G has no triangle. No point, no vertices of G dash can be adjacent to what? Both U and V in G. So this is most important thing. So they are telling, suppose if you take, because here you have what? 2n plus 1 vertices. If I take this vertex is either adjacent to what? U. Okay. This vertex is either adjacent to U. Okay. This is, they are telling a vertex in G dash which is not adjacent to what? Both U and V. They are telling. If it is adjacent, then if it will form what? A triangle. So that's why if you take any vertex in G dash, either it is adjacent to U or adjacent to V. Okay. Or it will not adjacent to anything. Okay. So it will not adjust. Okay. It will not adjacent to what? Uh, okay. Both the vertices U and V. So that is their first argument. Okay. So, and hence, suppose this vertex is adjacent to V means this will not adjacent to what? U. So if it is adjacent to U means it will form a triangle. So maximum number of edges from G dash to this U and V is the number of vertices in G dash. What is the number of vertices in G dash? 2n plus 1. So therefore 2n plus 1 edges from where to where? From the points in G dash to what? U and V. Okay. So either suppose this vertex is adjacent to here, this vertex is adjacent to here, this vertex is what? Adjacent to here. The next vertex may be adjacent to here. So similarly, 2n plus 1 vertices, I'll join either to U or to V. So I'll get totally uh, how many edges here from here to here? 2n plus 1 edges. Already I told that in G dash, maximum number of edges is what? N square plus n. Now from G dash to UV, we have what? 2n plus 1. Now in U to V, this one edge. So total number of edge in G, okay, maximum number of edges in G is what? N square plus n plus what? 2n plus 1 plus 1. 1 is this UV. Okay, maybe I'll write here n square plus n plus 2n plus 1, okay, plus 1. This is actually Q of G maximum. Q means number of edges in G. Okay, you can check it here. The next slide. So lines of G are of 3 types. Yes, the lines of G dash, that is we discussed. Okay, n square plus n. Okay, that is the lines in G dash in the diagram. I told that lines in G dash is what? Maximum n square plus n. Okay, n square plus n. Lines between what? G dash and U and V. So that is what? Less than or equal to what? 2n plus 1 maximum. So I told it is 2n plus 1. Okay. Next, the line UV. So the line UV, I told this edge 1. So totally you have what? Q or Q of G is what? Less than or equal to n square plus n. I wrote here n square plus n square plus n plus what? This 2n plus 1, 2n plus 1 plus this UV is 1. Now n square plus 3m plus 2 multiply and divide by what? 4. Multiply and divided by 4. So 4n square plus 12n plus 8 by 4. And then add and subtract 1 by 4. Okay, now okay, what is here? I'll write this one. 4n square plus 12n, 4n square plus 12n plus 9 plus 9 by 4 minus 1 by 4. Okay, but this is equal to, first you should write this is 2n plus 3 whole square by 4 minus 1 by I think mistake. Yeah, 4 now. For here also 4. This is 4. 1 by what? 4. But they are writing this is equal to the greatest integer not exceeding what? 2n plus 3 by whole square by what? Sorry. Whole square by 4. So you can check it. Suppose n equal to, I will put 5. Because up to n equal to be 4, we will verify. 5 means 10. 10 plus 3, 13. 13 square is what? 16. Sorry. 10 plus 3, 13. 13 square is what? 169. 169 by 4 minus 1 by 4 is equal to what? 168 by what? 4, which is equal to 42. Okay, wow. So from this we are getting what? 42. From this also we are getting what? 42. You can check it. So n equal to 5 means what you will get? So 169 by 4. So the 169 by 4, the greatest integer not exceeding 169 by 4 is what? 42. Similarly, you can check for n equal to 6, n equal to 7, n equal to 8. So this is same as this. Okay, so that is the observation. Next, okay, so Q of G is less than or equal to what? 2n plus 3 whole square by 4. The greatest integer not exceeding. Okay, so what is this 2n plus 3? Is the number of vertices in G. Okay, the number of vertices in G. You can see here the number of vertices in G is what? 2n plus 3. So p square by 4. So the maximum Q is what? The maximum number of edges in G is what? P square by 4. So that is actually we need to prove. For odd case we proved, But here they are going to give the example which graph attains the maximum number of edges. So for example, in our graph p equal to what? 2n plus 3. So the graph k, complete bipartite graph, k n plus 1 comma n plus 2. So what is the total number of vertices? 2n plus 3 has no triangles because complete bipartite graph, even complete graph does not have what? Any triangles. So this graph does not contain a triangle and has how many edges? N plus 1 into n plus 2 edges. So n plus 1 into n plus 2 is equal to n square plus 3n plus 2. What is n square plus 3n plus 2? Is what? Nothing but p square by 4. So this graph has no triangle and how many edges? P square by 4. Exactly it has p square by 4. Because here they'll put less than or equal to, but if we need a graph which exactly has p square by 4 edges. Which graph has? Complete bipartite graph with first partate is what? N plus 1. Second partate is what? N plus 2. It has no triangles. So this is k n plus 1 comma n plus 2. We should write like this: k n plus 1 comma n plus 2. Okay. The next case is for even p. Suppose p is an even number. Suppose the result is true for all even p, which is less than or equal to what? 2n. Okay. Suppose G is be a graph, p comma q graph. The next even number is what? P equal to 2n plus 2 and it has no triangles. As before, we will take what? Again, u and v. I'll take like this: u, v, adjacent vertices. Okay, adjacent vertices. And here, this is what? G dash. G dash. This is G dash. So from G, I am going to remove UV. Okay, or the vertex UV. So this is actually what? G. This is G. G has how many vertices? 2n plus 2 vertices. G dash has 2n vertices. G dash has 2n vertices. So by what is the assumption? The result is true for all even p less than or equal to what? 2n. So we know that G dash has 2n vertices and no triangles. By induction hypothesis, the result is true for what? G dash. The result is true for G dash means the maximum number of edges in G dash is what? Less than or equal to p square by 4. What is p here? 2n. So 2n square by 4. 2n square by 4 is what? N square. So the maximum number of edges in G dash is, this is edges. Okay, well, this is vertex. This is what? Edges is what? N square. The maximum number of edges in G dash is n square. Now, same thing again, same argument. Okay, if a vertex is adjacent to from a vertex in G dash is adjacent to U, it will not adjacent to what? V. Otherwise, we have a triangle. So how many maximum how many edges is possible? Here, how many vertices you have? We have 2n vertices. So from here to here, there are how many vertices? How many edges is possible? Totally 2n edges. Totally 2n. Here UV. This is what? One edge. So the maximum number of edges in G dash. Okay, what? Maximum number of edges in G dash less than or equal to n square plus what? 2n plus this edge 1. You can check it. So here the lines of G are three types. The lines of G dash. What is the lines of G dash? Just now we show that what? Maximum n square. Lines between G dash and UV. Lines between G dash and UV. How many we? 2n. So maximum 2n. And the line UV, that is 1. So the Q is nothing but the number of edges in G is less than or equal to n square plus 2n plus this edge UV is 1 is equal to n plus 1 whole square. So n plus 1 whole square you can multiply and divide it by 4. Okay, you can rewrite like this. Why I am writing write like this? Because here what is the number of vertices in G? The number of vertices in G is what? 2n plus 2. That's why I write in the form of 2n plus 2 whole square. Okay, divided by 4. So this is nothing but p square by 4. So we proved the maximum number of edges in G is what? P square by 4. So the result is true for even P also. So finally we are going to tell which graph attains exactly P square by 4 edges. For example, P equal to 2n plus, actually here G has what? 2n plus 2 vertices. That's why P equal to 2n plus 2 vertices. The complete bipartite graph K n plus 1 comma n plus 1. So n plus 1 plus n plus 1 is what? 2n plus 2. This graph, okay, is how many edges? Vertices is, we know that 2n plus 2. How many edges? N plus 1 into n plus 1. That is n plus 1 whole square. But the n plus 1 whole square is nothing but what? P square by 4. That's why they'll write P comma P square by 4. P means how many vertices? 2n plus 2 vertices. This graph has 2n plus 2 vertices. How many edges? The edges is, sorry, the edges is n plus 1 whole square. But n plus 1 whole square is same as what? Just now we showed P square by 4. So P square by 4. So this graph attains exactly, this graph has exactly P square by 4 edges. And also this graph does not have what? A triangle. So I'll stop here. Tomorrow we will discuss subgraph. Thank you.